Welcome my dear student, welcome to my channel Talking Physics with Piyas Sarkar. So today we shall learn with the torque, placed torque experienced by a dipole in an uniform and non-uniform magnetic field. So at first I ask you a question that if electric field is act along x-axis and two dipole, you know the dipole, two unequal charges are separated some distance 2a, this distance is 2a. So the two dipole are placed at an angle 120 degree, then what will be the magnitude of dipole moment, and what will be the direction of torque. Are you know the answer? Then solve it in your copy, or if you do not know this type of question answer, watch my video till the last end, because at first I will show you the basic theory and then at last of the video I will go with the answer of these particular questions. Okay. So what is the torque or what is the magnetic moment? What is the electrical moment in an electric field? So dipole moment, at first we find the dipole moment in uniform electric field. What is the value of dipole moment? Dipole moment in an uniform electric field and the torque experienced by it. Suppose the electric field acts along this direction. The electric field acts along this direction. Now a dipole moment, that is plus q charge and minus q charge, are separated by a distance 2a, are placed in an electric field with at angle theta with it. So what will be the force and torque? As we know that the force on plus q charge is along the direction of E field, that is F1 is plus QE and it acts along, F1 is plus QE and it acts along the direction of electric field, and the force in minus Q is minus QE, acts just opposite to it. So if we get the net force, that F net must be equal to plus QE and minus QE equal to 0. So my first conclusion is that in an uniform electric field, the net force on an electric dipole is 0. Okay, write down in your copy. Now we shall find out the torque. So what is torque? When two equal charges are separated by some distances, equal but opposite charges are separated by some distance, then a couple is produced and as well as a torque is produced. You know it from class 11. Okay. So what is torque? Torque is nothing but, what is the torque? Torque is the magnitude of force multiplied by perpendicular distance between force. So as we see from the figure that this is not the perpendicular distance. So we have to draw a perpendicular from plus q and minus q. So this is the perpendicular distance between the two charges. We say it as from the figure, this is a right angle triangle. If this is theta also, this is right angle triangle, then it is becomes equal to 2a sine theta. You know it from geometry. So the torque is written as tau is equal to the magnitude of force, that is F, multiplied by 2a sine theta. So we can get the value of tau equal to, put the value of F equal to QE into 2a sine theta. Now 2aq E sine theta. What is 2aq? 2aq is the dipole moment which acts from minus q to plus q along minus q to plus q, which is written by the vector p. So p equal to, so torque tau equal to 2aq E sine theta. What is 2aq? Is p E sine theta. In the vector notation, tau equal to p cross E. So in a uniform magnetic field, when a dipole moment is placed at an angle theta with the direction of electric field, the resultant force is 0, but the resultant torque does not 0. It is equal to the cross product of dipole moment and electric field. Now we go with the direction of torque. So to find out the direction of torque, we first go with the diagram. So as we know that the right-handed screw rule, which is said that if we rotate a screw, right-handed screw, then the tip, the direction of its tip go or advance is the direction of the cross product. So from the above definition, we can say that if the direction of electric field is along this direction of the figure, and P is along the direction making an angle theta, then direction of torque tau must be perpendicular to both P and E. And if we rotate a screw from P to E, then it would move perpendicular to plane of paper and into the plane of paper. So if we rotate a screw along this direction P to E, then it goes along downward direction. That is, if this is the page of paper, then it is perpendicular to page of paper and it is into the page of paper, is the direction of the torque. Now we can now get the value of torque, that is magnitude of torque, equal to P E sine theta. Now if case 1, if theta is equal to 90 degree, that is if E and P are perfectly perpendicular. So if the dipole moment is along the perpendicular to the electric field E, then tau becomes maximum equal to PE. And if E equal to 1, then tau equal to P, dipole moment. So we can define dipole moment in another way, that the dipole moment is the maximum torque. Dipole moment is the torque experienced by a dipole placed perpendicularly to the electric field of unit strength. Dipole moment is the magnitude of torque placed in an unit electric field perpendicularly to it of strength 1, that is E equal to 1. So we can define dipole moment as dipole moment is equal to the torque experienced by dipole placed perpendicularly in a electric field of unit strength, because dipole moment or dipole gives the strength of an electric field. So this is case 1. Now we go with case 2. If E and P are parallel to each other, so if the dipole is placed parallel to the E, then tau equal to PE sin 0 equal to 0. Okay. So we can say that the dipole moment in an uniform electric field is known to us, but now we go with the dipole moment or torque in a non-uniform electric field. In a non-uniform electric field, we shall go with the value of what it will occur in a non-uniform electric field. So in an uniform electric field, the total force is 0, but total torque is non-zero. So we can go with in non-uniform electric field. So non-uniform means the electric field is not same at all sides. So for non-uniform electric field, the electric field at different points the electric field will be different, E field will be different, and it is a function of position vector r of the dipole. So as the position change, then the magnitude of electric field change as well as the torque is also changed. So here we can deal with some two cases. Okay, what is parallel and anti-parallel? If the dipole moment is parallel, if P means dipole moment is parallel to E field, what it will occur? Parallel or anti-parallel. Okay, P is anti-parallel to E, parallel or anti-parallel. In the both two cases, torque will be 0. Why? Because torque tau equal to PE sin theta. So for parallel theta equal to 0. Therefore sin theta again 0, so tau will be 0. And for anti-parallel, theta will be 180, sin theta again 0, the value of sin theta again 0, so tau will be 0. But here the force will not 0, here torque will be 0, but force will not 0. here a force will act on the dipole moment in the direction of field. So we can consider here two cases, minus q plus q. So the direction of dipole moment is from minus to plus, always from minus to plus. That is, if the electric field are in the direction of the dipole moment, the force on plus q along this direction and the force on minus q is along this direction. But if E and P are in same direction, then force will increase. Force will increase in the direction of E, in the direction of E field. If P, that is dipole moment, and E are in same direction, then the force will increase in the direction of E field. Okay. Number 2, if the reverse case is occurred, that is, if this is plus q and this will be minus q, then the direction of P will be reversed. That is, it always, the direction of dipole moment is always from negative to positive, but the E field is now opposite to the dipole moment. So here the force will decrease in the direction of E field. The force will be decreased. So this is the basic phenomena of the dipole moment in an uniform electric field and non-uniform electric field. In the uniform electric field, we get that the force is 0, there is no translation motion occurred. It will, in the uniform electric field, the force is 0 but torque is non-zero. That is, the dipole will rotate. The dipole will rotate. In an uniform electric field, the force is 0, so no translation motions will occur, and the dipole is rotate perpendicular to the E field with an axis perpendicular to the E field passing through the midpoint of the dipole. Okay. So here rotation is possible, but the translation motion is not possible. Now we can do it with some practical example. If we know that the case of static electricity, if we run a comb in our hair and take it to the piece of paper which is electrically neutral, then the paper will attract towards the comb, because here the static electricity which is caused by the friction due to comb and hair, a static electricity is produced in the comb which induced a dipole moment in the paper, but here the field will be not uniform. It is non-uniform electric field which pull the paper towards the force of direction. So the paper attract towards the comb. Okay. Besides this, electric dipole moment has a very has a great importance in radiation technology of antenna and also in the effect or influence of electric field on the insulator. So electric field, dipole moment, torque has great importance in our daily life, in our practical life. Okay. So now we go with the example or question which I ask you at the starting of this video. So my question will, the two dipole moment, one is acts along y direction, minus q plus q, and another dipole moment, minus q plus q, are separated by each other with 120-degree angle, and electric field is along the direction of x axis. Then what will be the magnitude of dipole moment? So here if we say that the dipole moment is PA due to the first dipole, and again the dipole moment minus q to plus q, sorry, here the minus q and plus q. So again the another dipole moment Pb acts along this direction. So according to vector nature, we can, if we give that this is Pa and Pb, two vectors acts 120 degree. So as the two dipole are equal, so we can get the resultant dipole moment equal to Pa square plus Pb square plus 2 Pa Pb cos 120. So we can say Pa equal to Pb equal to P, as the two dipoles are identical. So P square plus 2P square cos 120 means half. That is P square plus P square, 2P square minus P square, that is P square. Root under P square means P, or equal to Pa equal to Pb. So it is the magnitude of dipole, resultant dipole. So as this is Pa and Pb, so the resultant dipole acts along the bisector, this is E field, along the bisector of the angle, that is in this direction the resultant dipole R is act. So this angle is 90 degree, Pa and E are 90 degree, and we know that this angle is 60 degree, okay. This angle is 60 degree. This angle is 60 degree, and this is also 60 degree. This is 60 degree, total 90 degree, so this is 30 degree. So now we go with the direction of torque. So direction of torque is tau equal to Pe sin theta. Now Pe sin theta means 30 degree, that is Pe by 2 sin 30 degree, okay. So the magnitude of torque is P by 2 and its direction is 30 degree, direction is 30 degree with E field or x axis, okay. Direction is 30 degree with E field or x axis, and the magnitude of torque is P by 2. So in this way we can write or get any numericals related to dipole moment and torque. So for today it is enough for you to understand and write. In the next day we shall go with electric lines of field or electric field lines, its nature and the related interesting topic. So if you want to know the actual physics or different physics in an easy way, please subscribe my channel and watch my video till the end. Do not skip or go to another channel if you like it. Okay, thank you.